Today we are going to discuss the methods of measurement of delta U and delta H. Here you can see an instrument that is a calorimeter known as bomb calorimeter. In this calorimeter at the center there is a part known as bomb. It is made up of a thick metal. And here there is arrangements to introduce oxygen. It is a substance holder where we can keep a non-mass of substance. And these are firing leads. When you pass electricity through these firing leads, it will make a sparks, and the sparks will help this substance for its combusting. It is an oxygen-rich region. When this substance reacts with the oxygen, what happens? Heat energy liberates, and that heat energy passes through this vessel and reaches here in water. Outside this bomb, water is there, and in the water you can see a stirrer on continuous stirring. The temperature distributes equally throughout the water, and here a thermometer. Initially, before the reaction, we can measure the temperature, and after the reaction, we can measure the temperature. The difference will give you delta T, and using the equation QV is equal to C into delta T, we can find out the internal energy change. QV is equal to C into delta T. QV is delta U. Internal energy can be determined from the temperature change in the calorimeter. Here the water will absorb heat energy liberated here, and therefore the temperature will change. Thus we can find out the heat energy liberated or absorbed at constant volume condition. It is a method of determining delta U or internal energy change. And for the determination of delta H, we can use another calorimeter. An ordinary calorimeter can be used. It is a simple calorimeter. It is a polystyrene cup. And inside the polystyrene cup, the reagents are taken. And a thermometer is immersed in these reagents. Before the reaction, we can note the temperature. And here also we can use a stirrer. And we can begin the reaction by adding the required reagent. And when you add the required reagent, stir it continuously, then the temperature will rise. If the reaction is exothermic, the temperature will rise, and finally it will become constant without change. As time passes, there may not be any change in temperature, and you have to note down that constant temperature. That will be the final temperature after the reaction. So here also we can measure delta T. Then using the equation QP is equal to C into delta T, we can calculate enthalpy change. Enthalpy change during the reaction, or the heat energy liberated at or absorbed at constant pressure condition. So these are the methods for the measurement of delta H and delta U. Now, enthalpy of a reaction. We can see what is meant by enthalpy of a reaction. Enthalpy of a reaction is represented as delta HR. Actually, we are writing it in this way, delta RH. But we can read it as enthalpy, change in enthalpy of a reaction. Change in enthalpy of a reaction. So what is meant by enthalpy of a reaction or a reaction enthalpy? It is the change in enthalpy of products, change in enthalpy obtained by the subtraction of total enthalpy of products. minus total enthalpy of reactant. Total enthalpy of product minus total enthalpy of reactants. That will give you enthalpy of a reaction. But practically it is impossible. It is not possible to measure the exact value of enthalpies of reactants and products. Practically that is not possible. So if you want to measure it, you have to find out some other equations. Okay, we can discuss on it. And to find out that equations, before that, you should know some other terms. What is meant by standard enthalpy of a reaction? The standard enthalpy of a reaction is the enthalpy change for a reaction when all the participating substances are in the standard states. Standard enthalpy of a reaction is the enthalpy change measured when all the participants, that means the reactants and products, are in their standard condition. What is meant by standard condition? For example, if you consider oxygen, oxygen is a gas at standard state, gas at its standard state, 1 bar pressure. At 1 bar pressure, at ordinary temperature, 298 Kelvin temperature, oxygen is a gas. That is known to you. That is the standard state of oxygen. For example, water. Water is a liquid at 1 bar pressure and 298 Kelvin. So the standard state of water is liquid state. The standard state of a substance at a specified temperature, is its pure form at 1 bar. Is its pure form at 1 bar. So standard enthalpy of reactions. If you want to understand standard enthalpy of reactions, we have to identify the different types of reactions. There are different types of reactions. For example, formation reaction, combustion reaction, atomization reaction, neutralization reaction. Such a number of reactions are there. So we have to discuss one or two such terms in order to understand what is meant by enthalpy of a reaction. First, we can see enthalpy of formation. What is meant by enthalpy of formation? Enthalpy of formation is the enthalpy change accompanied by the formation of 1 mole of a substance from its basic elements. 1 mole of a substance from its basic elements. That is important, from its basic elements. For example, H2O. H2O can be prepared in different ways, but enthalpy of formation of H2O is the formation of H2O from the elements H2 and O2. From the elements H2 and O2. So formation reaction of H2O can be represented as H2 in the gaseous state plus half O2 in the gaseous state gives H2O in the liquid state. Here the enthalpy change is known as enthalpy of formation of H2O, that is equal to minus 285.8 kilojoule per mole. Minus 285.8 kilojoule per mole. So for the formation of 1 mole of H2O, 1 mole that is mentioned here, that is specified here, 1 mole of a substance. It is the enthalpy change accompanied by the formation of 1 mole of a substance from its basic elements. It is the enthalpy of formation of H2. So in order to get 1 mole, we are using half moles of oxygen and 1 mole of H2. Another one, enthalpy of combustion. Enthalpy of combustion. What is combustion? It is the burning of a substance in oxygen. That is known as combustion. How can you define enthalpy of combustion? It is the enthalpy change accompanied by the complete combustion of 1 mole of a substance in excess oxygen. Enthalpy change accompanied by complete combustion of 1 mole of a substance in excess oxygen. For example, we can consider the complete combustion of 1 mole of hydrogen. This equation represents that. Complete combustion of 1 mole of hydrogen. In excess oxygen, only half moles of O2 is required. We will get H2 as the product, and delta H is equal to minus 285.8. So we can say minus 285.8 is the enthalpy of combustion of H2. Or we can say enthalpy of combustion of H2 is equal to enthalpy of formation of H2O. Enthalpy of combustion of H2 is equal to enthalpy of formation of H2O. In a similar way, we can find out such a number of reactions and changes. Enthalpy of phase transitions, enthalpy of allotropic reformations or transformations, allotropic transformations. As we already mentioned, enthalpy of neutralization, enthalpy of atomization, lattice enthalpy, bond enthalpy. Already we discussed such terms. Now, here we can discuss enthalpies of phase transitions. Which are the phase transitions? Liquid to gas, known as vaporization. Solid to liquid, known as fusion or melting. Solid directly to gas, known as sublimation. So enthalpy changes during phase transformations. First one, enthalpy of fusion. The enthalpy change that accompanies melting of 1 mole of a solid substance in standard state is called standard enthalpy of fusion or molar enthalpy of fusion, represented as delta H0 fusion. FUS, delta FUS H0. It is represented in that way. So what is enthalpy of fusion? This is the enthalpy change accompanied by the melting of 1 mole of a solid substance in its standard state. Complete melting of 1 mole of a solid substance in its standard state. That is enthalpy of fusion. Here, melting of ice is represented in this equation. 1 mole of H2 in the solid state undergo melting and forms 1 mole of H2 in the liquid state, and the enthalpy change during the process is known as enthalpy of fusion. That is equal to 6.00 kilojoule per mole. 6.00 kilojoule per mole. Enthalpy of fusion. Similarly, enthalpy of vaporization. What is enthalpy of vaporization? This is the enthalpy change accompanied by complete conversion of 1 mole of a liquid substance into its vapor state. So H2O in the liquid state is converted to H2O in the gaseous state, and the heat energy required for this conversion, that is enthalpy of vaporization, delta H vaporization, is equal to plus 40.79 kilojoule per mole. That is enthalpy of vaporization of H2O. Amount of heat energy required to vaporize 1 mole of a liquid at constant temperature and under standard pressure of 1 bar is called standard enthalpy of vaporization. Instead of this, what we can say? Enthalpy change accompanied by the vaporization of complete vaporization of 1 mole of a liquid at a constant temperature to its gaseous state. Now the third one is enthalpy of sublimation. Sublimation is the direct conversion of a solid into its gaseous state below its melting point. If it is getting its melting point, it will be converted to liquid. So the conversion of a solid directly into gas is possible below its melting point. Here two examples are given. Dry ice carbon dioxide sublimes at 195 Kelvin with sublimation enthalpy or enthalpy of sublimation is equal to 25.2 kilojoule per mole. Or naphthalene, its enthalpy of sublimation is equal to 73 kilojoule per mole. So standard enthalpy of sublimation, delta H0 sublimation is the change in enthalpy when 1 mole of a solid substance sublimes at a constant temperature and standard pressure. That is enthalpy of sublimation. Okay, I think it is enough for today. In the next class, we can see Hess's law.